Good day. Hope you are all looking at your sheet, which you should have been handed at the beginning of class. Today I'm going to walk you through chemical compounds. What are they? How do they form? But then last but not least, how to go ahead and actually be able to distinguish what is found in them. So the first question that we have in front of us is, what are chemical compounds? So most things in nature, when you talk about something like water, it's not a pure element. It's two elements that are chemically bonded together. So that's key to our chemical compounds. It's two or more elements and they're chemically combined. That chemical is important. So when we talk about something being chemically combined, take something like water, for instance. It's H2O. It's made up of two atoms of hydrogen, one element of oxygen. So if this balloon was a hydrogen-filled balloon, if I bring a lighter to it, it's going to blow up. But it's not a hydrogen-filled balloon because I didn't want to take that much time to capture hydrogen. So when we go ahead and put hydrogen, which is a colorless, odorless gas, which is super explosive, together with oxygen, which is the gas that we breathe that's needed for cellular respiration, you have two gases. When they're chemically combined, though, they make a liquid. And water is not explosive. It's not flammable. So when we chemically combine those two or more substances, they get new properties. The old properties, they gone. There's nothing about this that is flammable. There's nothing about this that is explosive. Its identity, it's new, it's different, it's changed. So once again, you can take two elements, boom, just put them together. That's a physical combination, okay? So I can't go ahead, look at my water, and take out the itty bitty pieces of hydrogen or the itty bitty pieces of oxygen. They are stuck, they are bonded. There's no going ahead and taking them apart unless you chemically once again change them. So that's the first one on your sheet. Make sure once again you are filling this in. Moving down on to, how can you tell what makes them up? So how do you tell differences between elements? So I gave you an example of H2O. Okay. Now note, capital letter, capital letter. Elemental symbols can either be one or two letters. However, when they're two letters, they're going to look different. Let's say you have something like CO. This right here, that is the element cobalt. However, you also have CO written like this. This is carbon monoxide. This is why you want to make sure you have your fish house vented properly, because if you have carbon monoxide buildup, it will go ahead and kill you, because carbon monoxide will bond more readily to hemoglobin in your blood than oxygen will. You'll get a headache, you'll start feeling tired, you think maybe you're getting ill, so you go ahead and you take a nap thinking you'll feel better, you never wake up. So the difference between these two is, an element, if it has two letters in its elemental formula here, it'll be a capital and a lowercase. Anytime you see two capital letters together, you know that you have two different elements. So this is carbon and oxygen. One tricky one that you'll see sometimes is this. Now, C is carbon, and you could also have I, which is iodine. However, those two elements never bond together. So about 99.999% of the time when you see this, as in something like NaCl, which is table salt, this is one element, this is another element. So the Na is sodium, the Cl will then be chlorine. So those are just a few real quick and easy ways to tell the differences between the different elements that go ahead and make up your elements. So anytime you see an uppercase and a lowercase, boom, you know this right here, one element. Boom, this right there, another element. This right here, one element, two elements, two elements, okay? So now when I said water is H2O, there's two atoms of hydrogen, we're gonna go ahead and go through some different rules now that are gonna help explain that. I'm gonna go ahead and erase my board real quick. If I wanted to do video editing, I would go ahead and leave this all, no, if I was gonna edit, I'd take it all out, but I don't really care. You guys probably are still writing down part of what I wrote, and you're probably like, don't erase it, but you're talking to a TV right now, so that's probably not gonna help you out at all. By the way, Joe, wake up. All right, so moving on, our next heading that we have is how much of everything. All right, so the first thing we're going to go ahead and discuss is a subscript. Oh my goodness, I think you talk about these in math class. You're going to see a lot of similarities here. So the first one that we're going to go ahead and look at here is a compound called glucose. We talked about it last year with photosynthesis and cellular respiration. So it's C6H12O6. So the subscripts here are these little numbers. Now, since these are little numbers, they don't have a very big reach. So subscripts are only going to go, by the way, I made that in the garbage. Subscripts are only going to go to the number directly in front of them. So on your assignment here, anytime you're giving a compound like this is how I want you to break it down. So right underneath the compound, we have C, that's carbon, that's one element that goes ahead and makes up that compound. We also have hydrogen, which is H. We also have oxygen, which is O. So that's the first step, breaking down, telling me you've got 1, 2, 3 different elements that make up your glucose molecule. Now we have to determine how many atoms of each element are there. So for the carbon, we know that there's 6. For the hydrogen, we know that there's 12. The oxygen, we know that there's 6. So in one molecule of glucose, we have 6 carbons, 12 hydrogens, 6 oxygens. If we only have 4 carbons, it's no longer glucose, it's a different molecule. Next one that we are going to go ahead and look at is, let's say we've got CO2. This is carbon dioxide. This is what you have in your paintball guns. It's also what you breathe out. So in this case, we have C, that's our carbon. We have O, that's our oxygen. Those are 2 different elements. Note, capital letter, that tells me that there's 2 elements there. So once again, you have a subscript. Subscript's a little short guy. He cannot get to the carbon. He only influences the oxygen right here. So we have 1 carbon, 2 oxygens. So that's subscripts. Now the next thing we are going to go ahead and discuss is going to be coefficients. So the reason why scientists use coefficients is because we are lazy. So with a coefficient, the coefficient is going to be a big number put in front of a compound. So instead of writing CO2 plus CO2, because we would have 2 molecules over there, we just go ahead and put this big coefficient out back there, or I should say out front. So that is a way that we go ahead and take shortcuts here. So the coefficient's a little bit different than the subscript because this coefficient, he's big, he's not small. So this, remember, can get distributed into both of these elements. So in this case, we have a coefficient 2 CO2. We have, once again, we've got carbon and we've got oxygen. So we've got 2 molecules of carbon. And then these numbers get multiplied now. So 2 times 2 is 4. We have 4 oxygen. So let's look at another compound. Let's say we have CO3. And let's say we've got a 3 there out in front. So once again, this 3 signifies that we have 3 CO3 molecules. So once again, when we go ahead and break this down, we've got carbon, we've got oxygen. So this 3 gets distributed in, this 3 gets distributed in. So we have 3 carbons. And then remember, we have 3 of these O3s. So 3 times 3, we would have 9 total oxygens that we're dealing with. Right, so that is subscripts and coefficients. Should be pretty easy, especially if you have not been completely comatose in math. Let's go ahead and flip it over. Now we're going to go ahead and look at parentheses, and then we're going to put everything together. So once again, if you need to go ahead and look at a few more examples or pause, go ahead and do that. But we're going to be moving on to the next thing, which is going to be Tucker, don't touch the person sitting next to you. Parentheses. Parentheses. Since this is going on YouTube, I should make sure it's spelled correctly. Parenthesis. Good. All right. So now, let's say we've got K, PO3, and a 4. So before we even go ahead and talk about what the heck do we do with our parentheses, let's look at the different elements we have. There's 3 elements that make up this compound. We have a K, which is potassium. We've got a P, which is phosphorus. We've got an O, which is oxygen. Note, capital letter, capital letter, capital letter. That means we've got 3 different elements. So the parentheses give these subscripts superpowers. They increase their reach. So just like in math, this number here is going to get distributed not only to the O, it's also going to get distributed to the P. So in this case, the K is not in the parentheses. So this 4 doesn't have anything to do with it. So we still only have 1 K. But for our P, 4 times, we only have 1 P there. So 4 times 1 is 4. We have 3 oxygens here, and we have that 4 times. So 4 times 3 would be 12 oxygen. So just like how you distribute in math, the rules are the same here. All right, so let's do one more here before we put it all together. So let's go CO2 with a 3. Now, internet police, I have no idea. I'm just making these compounds up in my head. If it doesn't bond, don't crucify me in the comment section. All right, so here, no, we've got capital lowercase, so we know that is going to be 1 element. That's calcium. Okay, we've got C, that's carbon. We've got O for oxygen. So once again, right here, this 3, this subscript, can it reach the Ca? No, but it can reach the carbon. It can reach the oxygen. So we've got 1 Ca, we've got 3 carbons, 3 times 2, we've got 6 oxygens there. So now we're going to go ahead, we've got 3 examples that are going to put everything together for you. So we're going to do these together on the board, and then your assignment for tomorrow, and you're also going to have a quiz on this, is going to be much the same. Almost done. make sure you do your work. You have an element presentation next week as well. Make sure you do that, or else you're going to look really silly. So the first practice one we've got in our notes is AL2, C, the board's not dry, CO3, with parentheses and a 3 around it. So once again, the first step is determining what we got going on here. Is this an AI? No, artificial intelligence on the periodic table. That's AL, aluminum. So your elements are, we've got Al, aluminum, or Al. We've got C for carbon. Got O for oxygen. So we've got our parentheses with our subscripts. So this little 3 is going to go to the oxygen. It's also going to go to the carbon. So we can start with our aluminum if we want. We're going to have 2 of those because it's down in the parentheses. We're going to have 3 carbon, and we're going to have 9 oxygen. Okay, that's the first one. Next one, we've got some NHs. So we've got parenthesis, NH4, close parenthesis 2, CO3. This is a good one to do because it's got parentheses in the front of the compound, not the back. So in this case, we've got N and H. There's no New Hampshire on the periodic table, so we know this is 2 different elements. We have N, which is nitrogen. We've got H, which is hydrogen. We've got C, which is our carbon, O, which is our oxygen. So when we go ahead and start distributing in here, this 2 is going to go to the H. It's also going to go to the N. So we're going to have 2 N's. 4 times 2 is 8 H's. Now the tricky one here is the C. I was going to say just like you read left to right, but that doesn't make sense. This 2 only goes to left. It can't go backwards to the C. So this C right here, there's only 1 of them. And then this 3 only goes to the O because there's no parentheses. So you're going to have 3 oxygen. So that's how you would go ahead and do that example. And we're down to one last one. On your quiz tomorrow, you're going to have to do 3 of these. I believe on your homework, you got 15 of them that you're going to have to go ahead and break down. So make sure you're not wasting your time. Also, I think you need to take like the NAEP test or something today, this week. Have fun with that. All right, so this last one, we've got 2 BA, then we've got parentheses C2, H3, O2, 2. So this is a good one to end on because it's got a coefficient, it has subscripts, it also has parentheses. So first step, once again, we have to look and see what elements we have. So we have Ba, which is barium, C, which is carbon, H, which is hydrogen, O, which is oxygen. Once again, if you need to go ahead and draw arrows to show where everything is distributed in, by all means, please go ahead and do that. Ooh, the fans just shut off. It's quiet now. All right, now we also have this coefficient. So this coefficient goes to everything. So we've got all sorts of stuff going on here. So in this case, we have 2 Ba, or 2 barium. Now we also have, oh man, we've got 2 coming over here. So we've got 2 times 2 is 4 carbon times another 2. So 4 times 2 is 8. Once again, we distribute this 2 in, but we also have this other 2. So 2 times 2 is 4 times this 2 is 8. Now for a hydrogen, we have 3 times 2 or 2 times 3, which is 6, times 2 is 12. Now for our oxygen, 2 times 2 is 4, times this 2 is 8. So that's how we go ahead and end up with 2 barium, 8 carbon, 12 hydrogen, and 8 oxygen. Once again, if you need to go back and watch this again, the link is in Google Classroom. Your assignment now is the Counting Atoms worksheet. You will go over that tomorrow, and then you will also have a quiz over that. So just make sure you're using your time, get your work done.